Let's evaluate the limit as x approaches 5 of the absolute value of x minus 5. So here this graph is from Desmos, and what I entered was, for y, I let it equal a, b, s, open parentheses. I put in x and close the parentheses, and I got this graph up here. So you should check that out in Desmos. But anyway, we're looking at 5, and as we approach it from both the left and the right, do we get the same value? As we approach from the left, the graph is moving down towards 0, and it stops like right at this point. So the limit from the left-hand side is definitely 0, but the same is true as you approach it from the right side as well. So since the limit from the left and the limit from the right are both equal to 0, that is going to be the value for part A. And just thinking ahead here, since this is a continuous function, that is, there's no like weird breaks or holes that appear in the graph, one way you can figure out this limit is by plugging 5 in place of x. So that would have been a valid approach as well. Like you could have said, oh, well, this should be equal to the absolute value of 5 minus 5. And if you follow order of operations, you would subtract the two 5s, and you get the absolute value of 0. And the absolute value of 0 is equal to 0. So for this question, it would be good enough to use a graph, and you could do that in Desmos. Or if you know that this function is continuous, you could just plug in the number and get your answer that way. For parts B and C of this same question, we're looking at the same function, but we're approaching from two different values. One is as we approach 3, and the other is as we approach 5. So because of this, in Desmos, I entered in a different equation. So this time, in place of y, I entered in the absolute value of x minus 5, but this appeared as a fraction, and here x minus 5 is in the denominator. And when I graph this thing, I have actually a horizontal line. There is a break in the graph, and then we have this other horizontal line. I'm going to actually add something to this graph that does not appear in Desmos, but this function, it's not defined at 5. If you put 5 into this expression, it's an undefined value. So what I'm going to do is just put an open circle here and an open circle here to indicate that at 5, the function just does not take on any value. Okay, so all that being said, let's figure out part B. So the limit as we approach 3. Okay, well, we're focusing on 3. As we approach from the left and the right, we're talking about this part of the equation. So as I approach from the left and I approach from the right, they're all going to the value of y is equal to, so that's really a -1, but it's going to this value here. So that means, for part B, the limit as x approaches 3 of the absolute value of x minus 5 over x minus 5, that should be equal to -1. Another way that you could have done this is simply by noting there's no breaks in the graph. The left and the right approach the same value. I think we could just take the number 3, put it into the function to get the answer for the limit, which should equal -1. I just want to verify this. So it's just another way of doing the problem. I'll put 3 in place of the x's, and I'll simplify it. The absolute value of 5 minus 3 is really the absolute value of -2, and in the denominator, 3 minus 5 is -2. The top, the absolute value of -2 is +2. The denominator stays -2, and what do you know? If you divide these two numbers, it verifies our work. We get -1. Now let's look at part C. Okay, this time we're focusing here, and clearly something odd is happening on this graph. Does this limit exist? Well, unfortunately, here we can't put 5 into the equation because the function is not even defined at this point. So what we have to ask ourselves is, as we approach from the left and we approach from the right, do we get the same value? Clearly, the answer is no. It would really be enough for this problem just to note that and say, well, this does not exist, and you could stop there. I'm just going to write out a little bit of work for it. So by that I mean the limit as x approaches 5 from the left of this function And here I'm getting this just by looking at the graph. As we approach 5 from the left, it's always equal to -1. But if you look at the limit as x approaches 5 from the right of the same function, okay, well this time it's approaching +1. So I'll put a positive for emphasis. These two things are different. It means overall the limit cannot be assigned one value, and so we just say it does not exist. Something else to watch out for here is, what if you just tried plugging in 5 into the function just like we did in part B where we plugged in 3? So like, what if you were like, all right, I'm not looking at a graph, I'm just gonna take the number 5 and put it into this function. If we do that, we get the absolute value of 5 minus 5 divided by 5 minus 5. If we simplify that, we get the absolute value of 0 over 0, and the absolute value of 0 is 0. But if you try typing 0 over 0 into your calculator, it's going to give you an error message. Like, this thing doesn't simplify to 1. It actually just does not equal anything. So like, if you took this approach, all it tells you is that you're not allowed to plug the number in place of the x's, but that doesn't tell you anything about the limit. Sometimes it might exist, sometimes it doesn't. And I think for this problem, a better approach is to maybe look at a graph of the function and go from there.